Hey guys, what would a unit in chemistry be without calculations? What we're going to be calculating today is going to be pH as well as hydronium ion concentration within a solution that's acidic or basic. So I just put this up here just to remind you a little bit about the fact that first of all, we have our pH scale, which ranges from 0 to 14. But one thing I wanted to make sure that you're recognizing is that as we decrease the pH, so as we're moving that direction, what we see is that the hydronium ion concentration goes up. Okay, so what we're really referring to is almost like how common they would be. If we have a pH of 0, that means that hydronium ions would be extremely common. We would have a lot of them in there. If we had a pH of 7, that means that they would be relatively uncommon. We wouldn't see them very often. All the way up at a pH of 14, it would be extremely uncommon. I said uncommon, whatever. And so the hydronium ion concentration would be relatively low. For calculating pH, it's a pretty simple formula. pH is the negative log of the hydronium ion concentration. So basically, and you're like, oh my gosh, logs! It's okay. There's a button on your calculator, and it looks like this, and it says L-O-G. And you just press it. And that's it. Okay. Well, you put negative before it. So you do negative log of the hydronium ion concentration. So if you read a question that says that the hydronium ion concentration is 1.0 times 10 to the negative 7th, then you would do the negative log of 1.0 times 10 to the negative 7th, which when you hit enter calculates to 7. So something with a hydronium ion concentration of 1.0 times 10 to the negative 7th would have a pH of 7. Here's another practice problem. We again have our hydronium ion concentration for our HCl solution. That's another thing to mention. HCl is, because it starts with hydrogen and it would dissociate and release a hydrogen, it's an acid. So when we look at this, we expect that the pH should be acidic. When we do the calculation, the pH comes out to 3, which is acidic. In this particular situation, we're looking at, again, calculating pH from hydronium ion concentration, and here we have a hydronium ion concentration of 9.8 times 10 to the negative 13 of sodium hydroxide. Sodium hydroxide is a base, so this pH should be greater than 7, okay, or 7.0 rather. So when we get that, we expect that it should be. We want to make sure we do it right. Negative log times 9.8 times 10 to the negative 13th gives us a pH of 12, which, yes, is greater than 7. Now, if you can solve for pH using hydronium ion concentration, then you can solve for hydronium ion concentration by using pH, because that's how algebra works. So given the pH equals the negative log of the hydronium ion concentration, we can manipulate that to be this formula down here, where basically we're saying that we take the inverse log. And if you do that, what you're essentially doing is we have pH equals negative log of h3o plus, sorry, that's really messy. We would divide both sides by negative log. And when you divide both sides by negative log, you take the inverse log. And the inverse log is basically going to be 10 raised to something. So we end up with the hydronium ion concentration equals 10 raised to the negative pH in this case, okay, which is the formula that's right there. If you're on your calculator, you also could hit second and then log, and then just put in the negative pH. Okay, so you could do it as 10 caret negative pH. If the pH is 2, it would be 10 caret negative 2. Or you could do second log negative 2. Here's an example problem for this. It says determine the hydronium ion concentration of H2SO4 solution that has a pH of 4. First of all, is the solution acidic, basic, or neutral? Well, the pH is less than 4, so that means it's acidic, right? And then to do the calculation, we would take 10 raised to the negative pH, which in this case is negative 4, and we get this value, which, when we change it out of scientific notation, is 0.0001 molar. It doesn't have to be in or out of scientific notation. Either one is totally fine, but if you wanted to do it, that is how you would do it, okay? And because this is a concentration, we get the unit molarity, capital M, on the end of it. Thank you guys, and I'll see you next class.